Hello everyone, welcome to my channel. Today we will discuss on 3 marks important questions on equivalence relations from the chapter Relations and Functions. In the previous video we have been worked with fixed 5 marks questions on on1 and on2 functions and also with invertible functions. So today we will cover 3 marks questions. Directly I will go through the question here. So the first question is, prove that the relation R defined on set of integers z is given by an order pair a comma b where 2 divides a minus b is an equivalence relation. This question is asked in 2014. Okay, we'll see how to prove this question. So already theoretically we know that if a relation R is said to be equivalence relation if it is reflexive, symmetric and transitive, right? So theoretically already we have been practiced lot, so today we will prove directly. So what is the condition? If R is reflexive, symmetric and transitive, then the relation R is what? Equivalence relation. So we'll work out the procedure here. First write the given data. The given is what? The relation R is defined on set of integers, that is z to z, given by the relation R is given by, it contains an order pair a comma b such that 2 divides a minus b. Clear? So first condition is what? Check out the reflexive condition. Okay, first we will check out reflexive condition, and you have to note the point that on which set the relation R is defined. Set of integers anta ide. So what to do? Let us consider for all and any integer a is belongs to z, for all and any integer a belongs to z, because they have defined the set on z na. So a is belongs to z. Consider an order doublet a comma a is belongs to my relation R. So reflexive condition means what? All the doublets should be present. So a comma a is belongs to R. So according to the statement, what happens? If an order pair a comma b is belongs to my relation R, then 2 divides a minus b. So a comma a is belongs to R means 2 divides a minus a, that is which is equal to 0, right? So definitely 2 divides 0, which is belongs to what? Set of integers. This implies for all any integer a belongs to z, my all the doublets a comma a is also belongs to relation R. Therefore your relation R is here reflexive. Simple, you have to write. Okay, and the next condition, it is symmetric. So symmetric condition we need to check out, that is reverse order pair should be present. That is, if a comma b is belongs to R, then definitely its reverse b comma a is must be present in my relation R. Then only it is symmetric. Okay na? So first we have considered one integer a here. Let for all any two integers a and b is belongs to set of integers z, consider an order pair a comma b. Consider an order pair a comma b is belongs to R, right? So order pair a comma b belongs to R. According to the condition, what is the concept they have given? It is 2 divides a minus b. Okay, from this I will check out. If 2 divides a minus b, then I will write 2 divides, so take minus outside here, it will be getting what? B minus a. So if 2 divides b minus a, read this sentence reverse. If 2 divides b minus a, then definitely an order pair b comma a is belongs to R, right? So we have proved if a comma b is belongs to R, then its reverse order pair b comma a is also belongs to R. Therefore for all a comma b belongs to z, if a comma b is belongs to R, then definitely b comma a is also belongs to R, right? Therefore you can easily write here your relation R is symmetric. Your relation R is what? Symmetric. And in the third condition, you need to check out about its transitive condition, right? ತುಂಬಾನೇ easy ಇರುತ್ತೆ. Just you need to practice the steps here. So transitive condition is what? Here we have taken two integers. No, for transitive condition we need to check 3 1. Let us consider for all a and b and c are the three integers belongs to z. Consider let a comma b, let a comma b is a order pair belongs to R. This implies what? 2 divides a minus b. Similarly, again consider and another order pair b comma c is also belongs to R. This implies 2 divides b minus c, right? a comma b belongs to R andre ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ 2 divides a minus b ಅಂತ ಆಗುತ್ತೆ. Again one more order pair b to c you have to check out. So b comma c is also belongs to R, means 2 divides b minus c. So if from this we can check out here, let me see, erase the some part here in order to prove the transitive condition. So go through this. So transitive condition is what? We have written let if a comma b is belongs to R, then we have written 2 divides a minus b. Again one more order pair b comma c is belongs to R. Let us consider. So according to the statement, what happens? 2 divides b minus c. You have to know that if 2 divides 4 and 2 divides 6, definitely 2 divides their addition also, 4 plus 6 also, right? That is 2 divides 10 also. In the same concept, if 2 divides a minus b, then 2 divides b minus c. This implies 2 divides those two numbers sum, that is a minus b and b minus c also. Here minus b and plus b will get cancelled, so remaining will be what? So 2 divides a minus c. So according to the statement, if you go through this, if 2 divides a minus b, then a comma b is belongs to your order pair R. So if 2 divides a minus c, then an order pair a comma c is also belongs to what? R. So according to that, I can write here your order pair a comma c is belongs to R, right? So from this you can conclude the statement that if a comma b is also belongs to R, b comma c is also belongs to R, then the another third order pair a comma c is also belongs to R. This implies if a comma b is belongs to R, b comma c is also belongs to R, then the third order pair a comma c is also belongs to R. This implies what? Your relation R is transitive here. Your relation R is transitive. Therefore you can write the conclusion that your relation R is here both reflexive, symmetric and transitive. Symmetric and transitive. Therefore here R is an equivalence relation. R is an equivalence relation. So usually you can get the 3 marks here, so you can go for that. Okay, so for the previous answer you have to check out, you can repeat the video here. We'll go for the next question. So one more question here. Define whether the relation R in the set A, where your relation R is given by x comma y, it contains an order pair x comma y, condition is given 3x minus y equal to 0 is reflexive, symmetric and transitive. Nothing but you have to prove that this relation R is an equivalence relation. This question asked in 2015 as well as in 2019. First you have to check out on which set your relation R is defined. On set A is given the elements they have given, and it is defined on relation R is given by x comma y equal to 3x minus y. So ಈ condition ನೀವು first target ಮಾಡಬೇಕಾಗುತ್ತೆ here. So let me go for that. First, given data you have to write what is given. They have defined a relation R on the set A which contains an elements 1, 2, 3, 4, 5, 6, 7, so on to what? 14. Okay, and the relation R is given. It contains an order pair x comma y such that 3x minus y is equal to 0 anta ide. Okay na? I can rewrite this as an relation R. It contains an order pair x comma y such that 3x minus y equal to 0. Then you can write y is equal to 3x, right? So 3x minus y equal to 0 na ನೀವಿಲ್ಲಿ y equal to 3x ಅಂತ workout ಮಾಡ್ಬೋದು, right? So now your relation R contains an order pair. First you have to write your relation R in terms of order pairs. Okay na? So ಇಲ್ಲಿ here if you want to check the reflexive condition, see reflexive means what? For every element of A it must contains an doublet. Clear? For every order pair, for every element of a set A it must contain an order pair which is in doublets. Correct? So let us take out this condition. Y is equal to 3x is the condition. You choose your all x value and find your y. Suppose if I take, see here, first they have asked what the relation R is, whether it is reflexive, symmetric and transitive or not, or you can check whether it is equivalence relation or not, right? So let us take out x is equal to 1 here, first element. Consider x equal to 1, what happens? So it is in the terms of what order pair. If you consider x equal to 1, your y will be what? So 3 into 1, that is 3 here. So first order pair is 1 comma 3, and the next value, choose x equal to 2. Choose x equal to 2, what happens? Y is equal to 3 into 2, that is 6. You will get an order pair 2 comma 6. And next check out for every value of A, that is 3 here, x equal to 3, then you will get y value as what? 3 into 3, that is 9 here. So order pair is what? 3 comma 9. And next check out the value 4 here. For x is equal to 4, you will get y value, that is 3 into 4, 12. So order pair is what? 4 comma 12. And the next for x value 5, if you take x equal to 5, your y value will be 3 into 5, that is 15, right? But here my 15 is not at all belongs to my set A. Therefore this order pair is neglected. Without 15, see all your x value and y value will present in your A set na. So here you can't take this order pair. So only we have 1 comma 3, 2 comma 6, 3 comma 4 and 4 comma 12. Now you have to check whether it is reflexive or not, right? So reflexive ಆಗ್ಬೇಕಂದ್ರೆ every element of set A it must contains its doublet. For example, ಇವಾಗ 1 ಇದ್ರೆ it must contain 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, so on. But here no order pair is visible, right? Here for all, let us take out for 1 is belongs to set A, and doublet 1 comma 1 is not at all belongs to my relation R, right na? Therefore here R is not reflexive. Here R is not reflexive. Clear? Next you have to check out whether it is symmetric or not. Clear? So check whether it is symmetric or not. So symmetric condition means what? If an order pair 1 comma 3 is belongs to R, its reverse order pair 3 comma 1 also belongs to R. But here in my relation R, 1 comma 3 is belongs to R, my relation R, but its reverse order pair 3 comma 1 is not at all belongs to my relation R, right na? Therefore here your relation R is not symmetric. So already you know the basic theory about reflexive, symmetric and transitive condition. That's why I'm going directly here without giving the hint. Okay, next we have to check out whether it is transitive or not. Transitive means what? Look at here. If an element, an order pair 1 comma 2 is belongs to R, and starting with 2 one more order pair is there. If it is 2 comma 5 is belongs to R, then definitely its order pair 1 comma 5 also must belongs to R. Then only the relation R is transitive, right? So you have to check out here. So just I have taken an example to give the idea about transitive. Now you look at 1 comma 3 is belongs to R, and starting with this 3 one more order pair is there, 3 comma 4, right? I will check out these two. 1 comma 3 is belongs to R, and 3 comma 9 is also belongs to R, right? Here an order pair 1 comma 3 is belongs to R, and starting with this 3 one more order pair is there, that is 3 comma 9 is also belongs to R. This implies the third order pair from 1 to 9, but that order pair 1 comma 9 is not at all belongs to my relation R. So if it is the case, then this implies your relation R is not transitive. Your relation R is not transitive. You have to check out the thing that here your relation is R is not at all reflexive, not symmetric and not transitive. Therefore your relation R is not equivalence relation. So easily you can write the answer here. Only 3 steps to go. Okay, so I hope you understood this. We'll go for the next question. Third one, see here. It is asked in July 2015 and September 2020. What is given here? Prove that the relation R in the set of integers. Again he has defined the relation R on set of integers, which is given by t and contains order pair x comma y, where x minus y is an integer. You have to show that. See, they only told you have to prove that it is a equivalence relation, right? So it means you have to satisfy all the 3 conditions, that is reflexive, symmetric and transitive. Clear? So reflexive anta show madbekadre you have to show and all the doublets should be present in your relation R. And if you want to show that it is symmetric, if you want to show that the relation is symmetric, for every order pair a comma b belongs to R, you have to show that b comma a is also belongs to R, means reverse. And if it is transitive, if a comma b is belongs to R and starting with b comma c is belongs to R, then you have to show the third order pair a comma c must be belongs to my relation R, then only it is transitive. They can take an order pair a comma a, or simply you can take x comma x or x comma y. Here you can write y comma x, x comma y comma z, then it is x to z. So depends upon the value they have taken here. So we'll go for the solution. So the solution part is what is given. Your relation R is defined on set of integers na. So relation R is defined from set of integers to set of integers, and the relation R is containing an order pair x comma y such that their difference x minus y must be an integer, is an integer. Clear? So you can prove in two way. One method is either you can go theoretically, or by taking an example you can prove this. Clear? So first I will check out the reflexive condition. So reflexive condition, what? For all you can choose any one integer x here. For all x is belongs to your set of integer z, let us take out, consider an order pair doublet. X is belongs to z means doublet x comma x is belongs to R, right? This implies, according to the statement, x is also integer, their difference will becomes what? Look at this, implies x minus x is an integer. Clear? Whether it is a yes, true or not, check out. X minus x is what? 0. 0 is also an integer, definitely. So 0 is an integer. Clear? You can take, instead of x you can take 1. So 1 minus 1, that is 0. Definitely 0 is an integer. This implies your relation R is reflexive. Your relation R is reflexive because for all x, your doublet x comma x is belongs to R here. Next you have to check out symmetric condition. So to check the symmetric condition, you have to check out an order pair and its reverse order pair. Okay, it means here I have taken x one value, here you have to check out 2. For all x and y are the two integers belongs to Z, consider an order pair x comma y is belongs to your relation R. So according to the statement ಏನಾಗುತ್ತೆ, if x comma y is belongs to R, then x minus y is an integer. Clear? This implies x minus y is an integer. Okay, by this sentence I will check out. Take minus outside here. If I take minus outside, it will becomes y minus x is an integer. Clear? So this implies x minus y is an integer, its reverse y minus x is also an integer. For example, if I take 1 minus 3, 1 minus 3 is what? Minus 2, which is belongs to Z. You reverse it, 3 minus 1, which is equal to 2. 2 is also what? Integer. So same concept here I have applied. Okay, just you have to show that their difference is belongs to set of integer or not. So yx minus y is also integer, its reverse y minus x is also an integer. According to the statements, if y minus x is an integer, then order pair y comma x is belongs to an relation R, right? Therefore we have proved if x comma y is belongs to R, then its reverse order pair y comma x is also belongs to R. This implies your relation R is symmetric. Simple sentence you have to write. Your relation R is symmetric. Okay. Next we will prove the transitive condition here. I hope you got the both reflexive and symmetric conditions. Okay. So take a screenshot. We'll go for the transitive condition here. Right. Next we'll check out transitive condition here. Transitive condition. So transitive condition check ಮಾಡಬೇಕಾದ್ರೆ ಇಲ್ಲಿ ನೀವು you have to check out 3 integers here, that is for all x, y and one more integer will take z. Small z is belongs to set of integers z. Consider an order pair x comma y is belongs to R. This implies according to the statement it goes x minus y is an integer. Okay, relation ಏನೆಲ್ಲ ಕಂಡೀಷನ್ ಇದೆ ಅದನ್ನು ಮಾತ್ರ ನೀವು ಚೆಕ್ಔಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ ಇಲ್ಲಿ. ಸೊ x minus y is an integer. One more order pair start with y, will check out y comma z is belongs to R. Again consider y comma z is also belongs to R. According to the condition, this will be what? Y minus z is also an integer. Okay na? Suppose take out 2 is also integer, 4 is also integer. Their difference 2 minus 4, or you can add 2 plus 4 is what? 6. That is also what? Integer here. Clear? Therefore x minus y is also integer, y minus z is also integer, then their addition, their sum is also an integer. This implies x minus y plus y minus z is also an integer. You can check out any value of xyz, definitely it will give the result as an integer again. This implies here minus y and plus y same procedure follow ಮಾಡಬೇಕಾಗುತ್ತೆ in a transitive condition. Minus y plus y get cancelled. What is remaining? X minus z. So x minus z is remaining. So x minus z is an integer. Clear? So if x minus z is integer, read the condition here. X comma y belongs to R means x minus y is an integer. So x minus z is an integer is nothing but an order pair x comma z is belongs to my relation R. Clear? So now we have proved, therefore for all an order pair x comma y belongs to R starting with y, one more order pair, and y comma z is belongs to R. This implies the third order pair generates here, that is x to z. Clear? That is x comma z is also belongs to R. This implies your relation R is transitive here. Your relation R is transitive. Therefore here your relation R is both symmetric, reflexive and transitive. Therefore your relation R is equivalence relation. Easily you can write your relation R is equivalence relation. This is the way how you have to prove. So 3 marks irutte, ತುಂಬಾನೇ ಸಿಂಪಲ್ ಸ್ಟೆಪ್ಸು, ಸೇಮ್ ಪ್ರೊಸೀಜರ್ ಫಾಲೋ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಈಸಿಲಿ ಯು ಕ್ಯಾನ್ ಗೆಟ್ ಯುವರ್ 3 marks. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶನ್ ವಿಲ್ ಮೂವ್ ಟುವರ್ಡ್ಸ್. Fourth question is there, March 2016 question. It is, we'll see how to prove this. So if you go through your NCERT questions easily, definitely you can achieve your goal. Okay, so what is given here? Here your relation R is defined on a set A where it contains an element x which such that x is belongs to z, set of integers which are lying between equal to 0 to up to 12. We have to write all the integers, and your relation R is given by it contains an order pair a comma b such that modulus of a minus b is a multiple of 4 anta ide. Okay na? Same step you have to follow here. We'll see what is given. First you have to write the given data. Given that set A, your relation R, it is defined on set A which contains an integers x which are from 0 to 12. So you have to write greater than or equal to 0 ide, it means you have to consider 0 also. So 0, 1, 2, 3, 4, so on to what? 12 ide. Okay na? So on to 12. Check out whether a minus b is a multiple of 4 or not. So you can't write all the order pairs by using calculation. It takes time, right? So I will give a shortcut method here. So what is your relation R is given here. Your relation R contains an order pair a comma b such that modulus of a minus b is a multiple of 4. Modulus of a minus b is a multiple of 4 anta ide. So multiples of 4 means what? All the tables of 4 you can check out. 4 is also multiple of 4, 8 is also multiple of 4, 16 is also multiple of 4, right? So modulus irodrinda here whatever the a value and b value you check out, the result will be positive multiple of 4. Clear? Therefore first we'll check out reflexive condition. So reflexive condition ಅಂತಂದ್ರೆ, for example if it is 0, 0 minus 0, 1 comma 1, 2 comma 2, 3 comma 3, all the order pair should must present in your relation R. So ನೀವು ಅದನ್ನು ಥೆರಾಟಿಕಲ್ ಆಗಿ ವರ್ಕೌಟ್ ಮಾಡೋದು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಇಲ್ಲಿ. that's what I will give you a short method. Theoretically you can prove this. Okay na? Let us consider for all. See, your A set contains what? All the x values which are belongs to what? Set of integers anta ide. Clear? So for all x is belongs to set of integers z. Clear? Or defined on what? Set A. An order pair. Consider an order pair x comma x. So doublets irbekalva. X may be 0, 1, 2, 3, whatever it is. Okay, so consider an x or doublet x comma x is belongs to your relation R. This implies according to the statements what? So instead of taking x, you better take a and b because they have given what? A and b na. So make a sort out here. So instead of x you can write a and abc. Okay, so check out A. Let us take out A is belongs to Z, then its doublets A comma A is belongs to R, right? So this implies, according to the statements, modulus of A minus B is multiple of 4 ide. So A comma A irodrinda idu modulus of A minus A is multiple of 4. Is multiple of 4. Okay na? So according to the statement, what happens here? A minus A is 0. So modulus of 0 is what? 0 here. Definitely 0 is also a multiple of 4. 0 is also multiple of 4. Yes, 4 zeros are what? 0. So 0 is also what? Multiple of 4 agutte. This implies for all any integer A belongs to Z, the doublets A comma A. The doublets A comma A is also belongs to R. This implies your relation R is reflexive here. Your relation R is reflexive. Okay. In the next condition, you have to check out symmetric. Symmetric condition. Clear? So here we have taken one integer. For symmetric condition, you have to check out two integers. Let us take out two integer A and B is belongs to set of integers Z. So those Z are lying between 0 to 12, which are present in set A. So A comma B belongs to Z. Consider an order pair A comma B is belongs to my relation R. Okay na? So according to the statement enagutte illi, if A comma B is belongs to R, then modulus of A minus B is multiple of 4. Write the statement as it is. Question alle answer irutte. Just you have to show your skill here. So modulus of A minus B is multiple of 4. Okay na? Now in order to prove symmetric, A B is belongs to R means you have to show B comma A is also belongs to R, alva? So look at this. By taking this sentence only, I will prove this. Modulus of take minus outside, as usual, same procedure. So symmetric conditionally you have to prove this. So take minus outside, what happens? They will interchange their place. So it becomes B minus A. Modulus, same sentence, is multiple of 4. Okay, this implies, since it is modulus, all the negative value will give you positive results. So it implies B minus A. Take minus outside because modulus will be always a positive. So modulus of B minus A is a multiple of 4. So if modulus of B minus A is multiple of 4, read reverse. B minus A is multiple of 4 means B comma A is belongs to what? Your relation R, right? So this implies an order pair B comma A is belongs to your relation R. So now you have proved if A comma A B is belongs to R, then it's reverse. B comma A is also belongs to R. This implies your relation R is symmetric here. Your relation R is symmetric. So without checking the values 0, 1, 2, 3, 4 and so on, you can easily prove by using this method. Elladukku same method apply agutte. Just go through this. Okay. Next condition is what? Transitive condition. We'll check out this. For reflexive, consider one integer. For symmetric, take out two integers. Shortcut and tricks it is. And for transitive condition, you have to check out three integers there. We'll see it. Transitive condition. So transitive condition ಏನಾಗುತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ. Let us take out for all any three integers A, B and C are the three integers belongs to Z. Consider C. Transitive condition ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? If A and B is belongs to R and starting with B and C is belongs to R, then the third order pair A to C also must belongs to your relation R. Then only you can say that your relation R is transitive. So first I will consider A and B. Consider A comma B is belongs to R. This implies what? According to the statement, modulus of A minus B is multiple of 4 ಆಗುತ್ತೆ ಓಕೆನಾ. ಆ್ಯಂಡ್ ಒನ್ ಮೋರ್ ಆರ್ಡರ್ ಪೇರ್ ಯು ಚೆಕ್ ಔಟ್ ಬಿ ಕಾಮ ಸಿ. ಸೊ ಬಿ ಕಾಮ ಸಿ ಬಿಲಾಂಗ್ಸ್ ಟು ರಿಲೇಷನ್ ಆರ್ ಅಂದರೆ ಏನಾಗುತ್ತೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇಟ್ ಈಸ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಬಿ ಮೈನಸ್ ಸಿ ಈಸ್ ಮಲ್ಟಿಪಲ್ ಆಫ್ 4 ಆಗುತ್ತೆ ಓಕೆನಾ. ಐ ವಿಲ್ ಗಿವ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಹಿಯರ್. 8 is also multiple of 4, 16 is also multiple of 4. their addition is also what? Definitely multiple of 4 ಆಗುತ್ತೆ ಅಲ್ವಾ. so 8 plus 16 that is 24 is also multiple of 4, that is 4 6 what 24 na. Definitely 24 is also multiple of 4 ಆಗುತ್ತೆ. this implies a minus b is also multiple of 4, b minus c is also multiple of 4, then their addition is also what? Multiple of 4 ಆಗುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ನ ಸೇಮ್ ಫಾಲೋ ಮಾಡಬೇಕಾಗುತ್ತೆ ಇಲ್ಲಿ, ದಟ್ ಈಸ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ a minus b ಪ್ಲಸ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ b minus c ಈಸ್ ಮಲ್ಟಿಪಲ್ ಆಫ್ 4 ಆಗುತ್ತೆ. ನಥಿಂಗ್ ಬಟ್ ಸೊ ಮಾಡ್ಯುಲಸ್ ಆಫ್ a minus b ಪಾಸಿಟಿವ್ ಆಫ್ a minus b and it is b minus c is multiple of 4. Nothing but here minus b and plus b will get cancelled. Remaining will be what? a minus c. Clear? So a minus c is multiple of 4. So a minus b is multiple of 4 is nothing but what? Modulus of a minus c is a multiple of 4. This implies, read the statement reverse. If a minus b is a multiple of 4, then a comma b is belongs to R. Here modulus of a minus c is a multiple of 4. This implies a comma c is the order pair belongs to your relation R, right? So now you have proved that a comma b belongs to R, b comma c belongs to R, then the third order pair a comma c is also belongs to R. This implies your relation R is transitive here. Your relation R is transitive. Therefore R satisfies all the condition of what? Reflexive, symmetric and transitive. Then you write the condition, your conclusion, that is R is equivalence relation. So ತುಂಬಾನೇ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ ಕನ್ಕ್ಲೂಷನ್ ಕೊಡೋದು. ಸೊ ಗೋ ಥ್ರೂ ದೀಸ್ ಥಿಂಗ್ಸ್. ವಿಲ್ ಗೋ ಫಾರ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಅಗೇನ್. So just carefully you observe the things here, then you can easily get the points, right? We'll go for the fifth question here. Again same method ide idu kuda, which is asked in 2016 and 2018. All are your NCERT questions which are asked in all the question papers of our previous board question papers. We'll see here. So ಏನಿದೆ ಇಲ್ಲಿ, your relation R is defined on again a set A ಅಂತ ಇದೆ, that contains 1 2 3 4 5 only 5 elements. ಸೊ ಯಾವಾಗ ಸೆಟ್ನಲ್ಲಿ ಫೈನೈಟ್ ನಂಬರ್ಸ್ ಇರುತ್ತೆ, ಈಸಿ ಲಿಮಿಟೆಡ್ ನಂಬರ್ಸ್, ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಗೋ ಥ್ರೂ ಡೈರೆಕ್ಟ್ಲಿ ಬೈ ಟೇಕಿಂಗ್ ದ ನಂಬರ್ಸ್, ಓಕೆನಾ. ಅದರ್ವೈಸ್ ಯು ಕ್ಯಾನ್ ಗೋ ಥ್ರೂ ದ ಥೆರಾಟಿಕಲ್ ಮೆಥಡ್. ಸಿ ಹಿಯರ್, ಆ್ಯಂಡ್ ಯುವರ್ ರಿಲೇಷನ್ R is given by what? A minus b. Sorry, make a correction that it is an order pair a comma b ಅಂತ ಮಾಡಿ ಅದನ್ನ. It is not, it is an order pair a comma b such that modulus of a minus b is even number. Modulus of a minus b should give you an even number is an equivalence relation ಅಂತ ಇದೆ. So we'll go for these things. This is asked in 2016 and 2018. ಸೊ ಡೆಫಿನೆಟ್ಟಾಗಿ ಈಕ್ವಲೆನ್ಸ್ ರಿಲೇಷನ್ ಮೇಲೆ ಪಕ್ಕಾ 3 marks ಕ್ವಶನ್ ಇದ್ದೇ ಇರುತ್ತೆ. ಸೊ ಯು ಕ್ಯಾನ್ ಗೋ ಥ್ರೂ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್, ಡೆಫಿನೆಟ್ಲಿ ಯು ಕ್ಯಾನ್ ಗೆಟ್ ಯುವರ್ 3 marks. ಓಕೆ, 5 marks 2 ಕ್ವಶನ್ಸ್ ಕವರ್ ಆಗುತ್ತೆ, ಆ್ಯಸ್ ವೆಲ್ ಆಸ್ 3 marks 1 ಕ್ವಶನ್ ಕೂಡ ಕವರ್ ಆಗುತ್ತೆ, ಆ್ಯಂಡ್ ರಿಮೈನಿಂಗ್ ವಿಲ್ ಬಿ 2 marks and 1 marks. ವಿಲ್ ಗೋ ಥ್ರೂ ದ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋಸ್. ಬಿಫೋರ್ ದ್ಯಾಟ್ ವಿಲ್ ಸಾಲ್ವ್ ದಿಸ್. ಸೊ what is given here? Solution part. Given that the set A is given with an elements 1 2 3 4 5. You can solve this question in 2 different ways, but I will go with my regular method which is easy for you. Same steps follow ಮಾಡಿದ್ರೆ ಸಾಕಾಗುತ್ತೆ ಇಲ್ಲಿ. Okay, your relation R contains an order pair a comma b such that modulus of a minus b is even. Modulus of a minus b is even. Okay na. So first as usual we'll check the reflexive condition here. So there is no need to check the order pair here by taking 1 2 3 4 5. Just you can go with the theoretical method, that only you can get your marks, no problem. Suppose for all, what is the element are here, a is there na, consider an element a defined on a set is what, a is alva. So for all a belongs to set a, consider its doublets. For example a is equal to 1 ಆದರೆ 1,1 ತಗೊಳ್ಬೇಕಾಗುತ್ತೆ, 2 ಆದರೆ 2,2 ಅಂತ ವರ್ಕೌಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. So now I have taken a, so you have to check out, consider its doublets a comma a is belongs to my relation R. So according to statement ಏನಾಗುತ್ತೆ, just you have to follow this one only. If a comma a is belongs to R, then modulus of a minus a should be what, is even. So ಇದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಟ್ರೂ ಆಗುತ್ತೆ ಇಲ್ವಾ ಚೆಕ್ ಮಾಡಿ. ಸಿ ಮಾಡ್ಯುಲಸ್ ಆಫ್ a minus a is nothing but what, 0. So 0 is also what, even number. Definitely even number are 0. Even number ends with 0 2 4 6 8, right na. So 0 is also what, even number. This implies for all a belongs to a, you have proved its doublet a comma a is also belongs to R. This implies your relation R is reflexive here. Only this much you have to write. Okay, next you have to go through symmetric condition. Symmetric condition, see for symmetric condition you have to check out two integers. For all a comma b belongs to set a. ಸೊ ಸೆಟ್ ಎ ನಲ್ಲಿರುವಂಥ ಎರಡು ಎಲಿಮೆಂಟ್ಸನ್ನು ತೊಗೊಳ್ಬೇಕಾಗುತ್ತೆ ನೀವು, a comma b belongs to a. This implies according to the statement, consider, okay, for all a comma b belongs to a, consider an order pair a comma b is belongs to R, right? So according to statement ಏನಾಗುತ್ತೆ, if a comma b is belongs to R, then modulus of a minus b is even ಅಂತ ಇದೆ. ಓಕೆನಾ, modulus of a minus b is even. Now I will do one thing here, as usual same step. A minus b is even, take minus outside here common, so it becomes what, minus of b minus a. Remember this, if you take minus common, these a and b will interchange their place. Okay, so continue the same statement, modulus of minus of b minus a is even. Okay, this implies modulus value is always gives you positive result, so minus will be becomes plus here. So again I will write modulus of b minus a is even here. Okay, again same step, a minus b is even. A minus b is even means a comma b belongs to R. So b minus a is even means an order pair b comma a is belongs to R ಅಂತ ಆಗುತ್ತೆ. ತುಂಬಾನೇ ಸಿಂಪಲ್ ಸ್ಟೇಟ್ಮೆಂಟು. Therefore for all a comma b belongs to R, your reverse order pair b comma a is also belongs to R. This implies your relation R is what here, symmetric. Your relation R is symmetric ಆಗುತ್ತೆ. ಓಕೆನಾ. ಸೊ ನೆಕ್ಸ್ಟ್ ವಿಲ್ ಚೆಕ್ ಅಬೌಟ್ transitive condition. Again I am repeating, for reflexive condition check out one element, here for symmetric check out two elements, for transitive condition check out three elements, that is a b c. If it is x, take out x y z likewise. So easy tricks it is. Those people who are struggling to get theoretical concept, tricky wise also you can solve this. So we'll go for the transitive here. Now we'll check out transitive condition. So for transitive condition here I will write, consider for all, let for all a b and 3, so that is c. So three elements you have to check out, a element, b element, c element belongs to set a. First consider an order pair a comma b is belongs to R. So according to the statement what happens here, a comma b is belongs to R means an order pair according to the statement, it becomes modulus of a minus b is even. Modulus of a minus b is even. Okay. Again, you consider one more order pair starting with b, that is b comma c is belongs to your relation R. This implies, according to the statement, what happens? Modulus of b minus c is also even. So ಇಲ್ಲಿ transitive condition ಅಲ್ಲಿ same step follow ಮಾಡ್ತಾನೆ ಇದೀನಿ ಇಲ್ಲಿ. Here also you have to maintain the same step, that is you just add these two, because if 4 is even number, 6 is also even number, then their addition, their sum, 6 plus 4 is what? 10. 10 is also what? Even. That is sum of two even number is always a even number, so just you add it. This implies modulus of a minus b plus modulus of b minus c is a even number, right? Now their addition is also will give you even number. According to this, I can write simply a minus b plus b minus c is even number. Here minus b plus b will get cancelled. Same step, what is remaining? A minus c is left out. A minus c is left, so a minus c is also what? Even number here. If a minus c is even, definitely you can write it as modulus of a minus c is even. This implies an order pair a comma c is belongs to your relation R, right? So now you have shown that a comma b is also belongs to R, b comma c also belongs to R, then the third order pair a comma c is also belongs to R. This is like a chain, right? AB belongs to R, BC belongs to R, then the third order pair A to C is also belongs to R. This implies your relation R is transitive here. Your relation R is transitive. Next conclusion you have to write, therefore here R is both reflexive, symmetric, transitive, hence it is equivalence relation. Hence it is equivalence relation. Write the conclusion properly, then only you will get the full marks. So same steps you have to follow, whatever the question it may be, depends upon the set, you can write according to it. Okay, we'll move towards the next question. Hope you understood this. Just take a screenshot of this. We'll go for next one. Okay, we'll go for the next slide here, sixth one. Okay, this is also one of the trickiest question. Most of the students will commit a mistake there. So ತುಂಬಾನೇ easy ಇದೆ question, ನೋಡೋಣ. Solution. For the solution part, first you have to write what is given. Show that the relation R defined in R only and is given by. So the relation R is defined in a set of real numbers. This R is what? Set of real numbers. Relation is denoted by R. Okay na? It contains an order pair a comma b such that a is less than or equal to b is reflexive, transitive but not symmetric anta ಹೇಳ್ತಾ ಇದ್ದಾನೆ. Okay na? We'll see this. Given that your relation R is defined on set of real numbers. Remember, set of real numbers. So real number contains both positive numbers, negative numbers, integers, irrationals, rationals, right? Okay, now the relation R is given by, it contains an order pair a comma b such that a is less than or equal to b anta ide. By taking example also you can prove this. First I will write